Alright guys, so it's me again, and I just want to explain a few reaction concepts to some of my friends who are in civil engineering and in the first year. Very important concepts. This is your sort of path to structural analysis, and then from there on, and it also helps in concrete and steel structures, okay? So let's get into it. So this is our basic sort of a beam, okay, and with two reacting supports. And yeah, let's analyze them. So let's actually name this as A and B, okay? And so obviously, if you want to find the reactions that you know that this one's a pin, this one's undergoing here, and this one is just a roller, so there's no X forces, it's just this one, okay? And we'll talk about the moment in a sec. Okay, so this one here, so there's a load at P, a load of P at L over 2, okay? So L over 2 is here, okay? It's not your ideal diagram, but, okay? L over 2, okay? So we know that AY, and this one's going to be our BY, okay? This one's going to be our AX, and that one doesn't have one. So AX, straight away we know, so the sum of the forces in the X direction is 0 because there's literally no force acting on the beam. It would be interesting if there was an actual force that's going this way, but not in this case, so we'll just take that as 0. Okay, now, straight away, in the Y direction, has to be 0. So in the Y direction, in equilibrium, I'd say AY, okay, this is my positive sign. The positive sign is upwards, okay? So AY plus my BY, okay, equals P, okay? P. Now, actually, it's a minus P equals 0, okay? Minus P actual equals 0 because like I said, my direction is going upwards, so forces that's going upwards is my positive ones, and this one is coming down, so it's going to be a minus. So now I can rearrange this to this one like you saw earlier equals P, okay? Now the next part is to actually find these reactions. So now, moments, okay? So my moment around A, moment we're going to take as anti-clockwise being positive, okay? So our clock goes this way, right? But we're going to take this as our positive, okay? So plus, minus, okay? So if I say, okay, moment equals 0, okay? So that is just give me 4. Okay, so all the forces, AY is at 0, eliminate, because the moment is acting around there. And the next part is my force, okay? So the force is acting, the load is acting at point L over 2, okay? So I'm just going to write negative P, because my direction, okay? Because this one here is going to take, this going downwards, it's going to go to a clockwise direction from here, if you think about it. Yeah. You see what I mean? So, negative P at L over 2, distance L over 2, because remember, moment equals length times force, okay? So at arm length, and if I have an object here, if I have a load here on the most far end of my arm, that's when the max moment is, okay? That's where the max moment is. The max moment won't be actually on here. Moment equals torque, okay? So, torque comes from physics, which you should already know. Okay, so now, next part is my B. Now, the sign here is going to be positive because, like I said, this one is always going to be positive, and if you think about the moment, it's going this way, it's going to be pushing upwards, so that's anti-clockwise. So yeah, so BY at L over 2, plus L over 2, that is my L equals 0, okay? So now, rearrange this, bit of an algebra to do. So this one is just PL over 2, it goes the other way, and then just write the whole thing by L. It's going to be P over 2, okay, P over 2. Now, come back to this equation here. Okay, so AY plus my P over 2 equals P. Y is just going to give me P minus P over 2, which is also equal to P over 2. Okay, hope that makes sense. This is just a basic example, but it's very handy to know. Thanks. Alright, so now we have another question. We'll use numbers this time. So yeah, let's get into it. Again, we have a pin and we have a roller. So straight away I'm just going to draw the supports, AY, AX, okay, and this is my B, so I'm just going to go BY, okay, roller. Okay, so this one, so as you know, in the last example, forces in the x direction equals 0, forces in the y direction need to equal 0, therefore I'm just going to go, so AY plus my BY, and my positive is going upwards, right, BY minus, if I go, this one is coming down, so if I can just go 10 plus 20, okay, I'm just going to write this because some people might not understand what I'm doing, okay, 0, okay, so, and that is just 30, so I'm just going to write that out, I'm just going to write 30, okay, equals 0, so now we know that AY plus BY equals 30, okay, now next part is to find the moment. Okay, so now the moment around A, because that's the pin, okay, so equals 0. Now remember the moment part is anti-clockwise, is more positive, right? So I'm just going to go, okay, so at AY is 0, so the next one is my 10 kilonewtons force, okay, so I'm just going to come here, I'm just going to go, okay, so 10, but remember the last one, it's negative, okay, so 10 at the distance, so negative 10, 2. Now the next one is negative again, 20. What's the distance? 4 plus 2, so 2 goes out this way, so 2 plus 4, that's 6, okay, so 20, that's 6, so that's 20 at 6. Now the next one is BY, which is going upwards, which is going in the anti-clockwise direction. So this one is BY at 2 plus 4, 6 plus 2 is 8. Okay, that equals 0. Okay, the next part is, okay, I'm just going to write algebra. It's just basic algebra. Okay, so that's my 20 plus, because I'm going to take it to the other side. That is 120. Okay. 120. Okay. Okay. Let's just write a BY. Okay. So now the next part is B1 equals. That is just equal to 140. Okay. So 140 divided by 8. Okay. So 140 divided by 8. Calculator. So now 140 divided by 8. That is 17.5. 17.5 kilonewtons. Okay. Now the next part is getting back into this one. So now AY plus 17.5 kilonewtons actually equal to 30. Okay. So AY is going to give me 30 minus 17.5. 12.5 kilonewtons, okay? So that's that. Okay, so at AY there is a force of 12.5, or the reaction force is of 12.5 kilonewtons when there's 30 kilonewtons acting on different regions across the beam, and then the BY there's a 17.5 kilonewton reaction force acting, okay? So hopefully that makes sense, and hopefully that's an easy sort of a method. And if you understand your signs and your conventions and that, then you should be sweet, okay? Alright, thanks so much for that.